Hello again. So I'm once again going to showcase some ways to use computer assistance when formalizing in Lean. This time I'm going to showcase more Github Copilot, which I did use a little bit in my previous videos, but mostly as kind of a fancy autocomplete, which is basically the main use case for GitHub, I think, when you are already very familiar with the syntax and you already know roughly what you want to type in, and then GitHub can sometimes accelerate that a little bit. But actually, GitHub is also very useful when you're just starting out, at least for Lean, because it can supply for you quite a lot of the basic syntax and commands if you're not familiar with them. But you do have to prompt it appropriately. So I'm going to illustrate this with just some programming where I'm going to do some basic exercises in analysis. Okay, so I will start by describing what I'm going to do. So file, we are going to give some epsilon delta proofs of facts about limits of functions. So let's begin. Let's say I want to show that the sum of two limits, the limit of a sum of functions is still a limit. Okay, so let's say first we show that. I have to first define what convergence means. Okay, so first we give the epsilon delta definition. Function f, so from zero line to zero line, to converge to a limit L at a value x naught. Okay, so this will be a definition. And GitHub Copilot has given me, I think, the limit definition of 1. Okay, so so this definition defines a predicate limit FL x naught, where v epsilon is a delta, such that for all x, the absolute value of x minus x naught is less than delta. Yeah, that is actually the correct definition. I prefer to use the absolute value signs. Okay, so I'll just change that. Okay, so this is my definition. Yeah, we can do that. I don't want to do that. Okay, so let's prove. Okay, first we show that if a function f converges to a limit L x naught, and a function g converges to a limit m at x naught, then f of g converges to L plus m. Yeah, that is what I want to show. So let's see, get the lemma. Let's say, okay, so GitHub Copilot is suggesting me something. Let's have a look at it. Okay, so limit add, if f and g are real, L and m are real, f, g are functions, L and m are real, x naught is real. If limit f, L, x naught, which is our notation for f tends to L at x naught, and g tends to m at x naught, then the function f plus g tends to L plus m at x naught. Yeah, this is the correct definition. Okay, so let's have a look at what it's doing. Let's see, where is the goal? Right, so initially we know that we have these two hypotheses, but they're stuck in as inside the implication, so the intro will pull them out. Okay, so H1 and H2 get pulled out as statements, and then the epsilon and H epsilon, which are implicit inside the limit definition, also get pulled out. So epsilon is a real number and it's positive, and we want to prove that there exists a delta such that this is true. Okay. Then they are splitting. Okay, so H1 epsilon, H epsilon is the statement that basically F converges. That there's a for the specific epsilon with this positivity condition, there exists a delta. So our case is just pulling out the explicit delta. So we have this delta 1, it's positive, and we know that if x minus x naught is less than delta 1, then f of x is less than L. I don't like those. I think I'll ask for that to be subscription. And of course, well, all right. I was actually hoping for, yeah, let me just do it myself. And then, yeah, okay, I can change all the other things for me. All right. Okay, so we pull out the epsilons and deltas for F1 and F2, and then you take delta to be the minimum of delta 1 and delta 2. Yeah, that's the right move. Yeah, then we have, okay, this is wrong. We want to select a delta and prove that it's positive. But you can't just take, yeah, so I mean, delta 1 is positive and delta 2 is positive, but you can't just take, min-pos doesn't quite exist. I'll just complain to Copilot about this. Okay, so this use statement is correct. Delta that is not justified is your property. We can just say that, it's just we'll fix it. All right, so it's right, so we are using okay, we use delta. Split is not the right tactic here. Actually, if you want to split an AND statement, you should use something like constructor. Let me see if actually GitHub knows about this. Yeah, okay, it does know what constructor. All right. No, but it didn't. Well, okay, I'll just do it manually. Okay, so now it did. Okay, so we have a delta and we need to verify that it's positive, and it obeys this condition here. Positivity, it was verified correctly. Okay, it is the minimum of delta 1 and delta 2, but the method used was not correct before. Okay, so now we need to prove that for every x which is within delta of x naught, f plus x is within epsilon of L plus m. So we introduce this. Okay, so x minus x naught is less than delta. So then GitHub says, therefore, it's less than delta 1, which is true, and less than delta 2. Okay, so now it's going to set up a calc block. Yeah, so we're going to prove this by a big chain of inequalities. But calc doesn't have this epsilon, this colon shouldn't be there. So let's just fix that. Okay. Also, this by ring should not be there as well. Okay, so I'll just ask Copilot to fix that. All right. Okay, so it has now broken up. Yeah, so we want to get from fx dx minus L plus m to epsilon, and so it's breaking up into. Okay, so this is rearranging the terms, then triangle inequality. Each term is bound by epsilon. So that's 2 epsilon. Ooh, okay, and there's something. There's something wrong at the end. 2 epsilon is not bound by epsilon, but let's deal with that later. And so they're claiming that fx plus gx minus L plus m should be equal to fx minus L plus gx minus m. Yeah, that is correct. But yeah, so simp is the catch-all. Simp tries to simplify both sides by sort of standard obvious things like canceling. But it didn't quite work here. Now, there are several ways to do this, but I'm curious. Let me just get a general query first. Okay, so GitHub provided a correct alternative. Yeah, so there's a method there's a lemma called add sub add com. Yeah, that if you take a sum, an addition a plus b, subtract another addition c plus d, then in Mathlib there is already a lemma that rearranges that sum, and that's actually exactly what's needed here. Okay, right. So here there is a problem, and it is a standard issue that if you have in analysis, if you have try to combine two estimates which lose an epsilon, you're not going to lose an epsilon at the end. You're going to lose 2 epsilon. But it's a standard way to fix that is that you replace epsilon with epsilon over 2 from the very beginning. So maybe I'll just tell GitHub to do that. Work, the epsilon is twice as big as needed. Can you rewrite the argument to use epsilon over 2 instead of epsilon at the beginning? So that's the last step of that. Okay, so let's see. Okay. And now it has compiled. So we have actually proved this lever mostly through just prompts to GitHub Copilot. There are still issues, so you do have to stay on top of what's going on, but the fact that it's interactive is very nice. Now, usually, once you have one example, you should be able to do similar things. It should be easier to provide variants of the same statement. So let's try, okay, similar argument also works with differences. So now that we've proven a lemma for sums, we should be able to prove a lemma for differences. Okay, so that's the correct statement. So it has given us a very similar statement. And it's using epsilon over 2. It's copying the previous proof. Okay, so things are also, so everything's compiling except for one line. So we need to, yeah, sure, fx minus gx minus l minus m is equal to f of x minus l minus g of x minus m, which is correct. Okay, yeah, so it hallucinated a method sub cancel, which doesn't actually exist. So, well, okay, I know several ways to fix this, but let's just ask Copilot, okay, sub cancel doesn't exist. There are other ways to proceed here. For example, canceling the after values first. So I can give it a hit to see what happens. Oh boy. Okay, so it's trying. Yeah. Okay. So, oops, I lost that. Did I get? Does it remember what I just did? Okay. Yeah, you can manually get from here to here by doing lots of binary swaps. So there are lots of little lemmas that are designed to just swap 2 or 3 of these sums and differences. That would work, but that's a rather painful way to proceed. I don't like that one. So let's see. Yeah. First of all, yeah. Okay. I'm trying to see if it knows that the tactic for canceling. So detailed, I'll do it anyway. All right, no, so it's actually struggling with, okay, so here I think I'm going to give up and do it manually. Okay, so there are several ways to proceed here. The tactic I was looking for was congruence. Congruent is a tactic that matches, when you want two things are equal, it tries to match the arguments as much as possible, except that it did it too much. So when I did it here, it says I'm going to reduce this to showing that gx equals L, and I guess also L equals gx, which is not what I want. So I actually only want to do one level of congruency. Yeah, so then I have this, okay. So this is just an algebraic statement. Okay, let's see if GitHub can figure out how to do it from here. I'm not sure if GitHub can actually see the proof state. But let's see. If it has a clue. It's still inventing a technique that doesn't exist. Yeah, so basically, Mathlib didn't supply a technique to do exactly this. This is an identity that holds in all abelian groups. So actually, I know that the technique Abel, which is designed to prove identities that hold in abelian groups, just works. So I'll just close it by myself there. Okay, so here, GitHub, I would say, got a B plus. It did a lot of the work, but there was one step which really confused it. Let's try something even more challenging. Okay, now let's try the trickier work with products of functions rather than sums of differences. So this one, the epsilons get more messed up. Let's have a look. Okay, so here's GitHub's attempt. Let's just read the statement. The statement looks good, at least. Okay, it's trying something. Okay, so the strategy it's shooting for is it's going to approximate after accuracy epsilon over 2m plus 1 and epsilon g to l plus 2. Okay, that has a chance of working. Didn't finish the argument. All right, we'll go over this group. Okay, so it wants to first do some positivity. They need this thing to be positive. Yeah, now, so there are all these atomic lemmas that, for example, div pos is the lemma that if A is positive and B is positive, then A divided by B is also positive. GitHub is trying to use all these little lemmas, but actually there is a general purpose technique for positivity, which sort of applies all of these at the same time. Yeah, so I think I'll just do that instead. All right, so it is applying continuity of F with this error tolerance and continuity of G with this error tolerance. Okay. Right, so we're going to use the better of the two deltas. Yes, and we're going to use it. Yeah, maybe do a constructor split. That's right. Yeah, and again, the positivity is LT min. That's correct. Okay, the tabbing is not correct. Okay, so we have to introduce X and HX. Okay, so we do that. Good. Okay, and it's setting things up. Yeah, so because X minus X looks less than delta, then it's also less than delta 1, correct? Less than delta 2, good. Right, Fx minus L is less than epsilon over this. Yeah, that's because of what we defined. Yeah, okay, so I will take that. Okay, yeah, so we have an approximation F, G. Oh, okay, it is also going to upper bound F by L plus epsilon over. Okay, yeah, I can see why we're going to need, yeah, this is true. The proof is not correct. Yeah, this is just the triangle inequality coming from here. Oh, but it's pretty close. Okay, yeah. So here, yeah, Arbo didn't work. Yeah, Arbo didn't work here because of the absolute values. Let's just see if come on, fix this. Okay, yeah. So it turns out there is a specific lemma, sub add cancel, A minus B plus B cancels to A, and that works there. Okay, here we are bounding this by, okay, so Fx minus L. Okay. This is pretty close. Okay, so here Copilot is trying to bound Fx minus L plus L by epsilon over 2m plus 1 by L. Fx minus L is bounded by epsilon over 2m plus 1. That's H1x here. But L is not strictly less than L. It's equal to L. So it's using the wrong method. Add less than add requires both terms to be strictly less than the counterpart on the right hand side, but here one of them is equal. Well, okay, so okay, now I'll just ask Copilot to fix this. What's the let's see what it does to. Okay, okay. So it in fact used a more powerful technique. Yeah. So actually, there's a linear arithmetic technique that any inequality that is a consequence of existing inequalities by linear arithmetic. So fx minus l plus l being bounded by this is actually just a consequence of this that's already in the state. So it just did that. All right. So we have this bound. Okay, we bounded f. Sure, we can bound G as well by a very similar thing. So, all right, we did that. Okay, so now we need to prove our bound. So let's see how it will try to do that. Right, so we're trying to bound the difference between fx times gx and L times m. So it's doing the standard tricks of adding and subtracting intermediate terms. This is a standard analysis trick. Yeah, again, it's appealed to Arbo to justify the first line, but that doesn't work because of the absolute values. But I think if we just do Congo first, then it works. Yeah, and I think that's something that will work here. Okay, then apply the triangle inequality. Okay, now here, oh, hang on, there's a problem here. Abs add is not working. Hang on, also this Arbo is not working either. This is no longer, this is not an abelian group identity because this application is a ring identity. Okay, okay, I have a separate for that. Okay. All right, yeah, abs add is a triangle inequality. By the way, in Lean, you may think the names of these lemmas are a bit weird, you know. So this lemma is saying that a plus b absolute value is less than a plus b. So you ask, why don't you just call it a triangle inequality? They call it abs add because that's a unified naming system. It makes it easier to find these inequalities if you're not using Copilot. The triangle inequality involves the absolute value of an addition. So the standardized name for it is abs add. But that's almost what we need here. But you see, if you do abs add, the absolute values get put on the outside, not on the inside. So this is only one of the two steps. So let's just get Copilot to fix that. It leaves the absolute values outside the product still rather than inside. We need two steps here. So we need something to move the absolute values inside the product. That's probably so that the name of that's going to be something like abs mul. That's why the naming system is so useful. So let's see if it fixes it. Okay, it's very clever. Yeah, so so it first uses abs add, and then it moves the absolute value inside by two applications by abs mul. Good. Right. So then we're bounding fx by this. So he wants to use, they want to use bound for f, which we have, bound for g minus m that we have, bound for m that we have. Yeah, okay, so yeah, this is pretty straightforward. The one thing is that it's not linear arithmetic because again, there's a multiplication and you're messing with both sides. This may be okay. So there's a generalized congruence tactic. What's here? Oh, but unfortunately, it needs m. It almost worked actually. The problem was that it requires m to be positive, which we are not actually requiring. What's the easiest way to fix this? Actually, I want to split it into two inequalities. One is so m can vanish. So I want so this guy can be positive equality, but the first guy will be strict. Let's see. Say no, it's not that at all. Okay. Yes, I want to split it up into a strict one on the left and a non-strict one. The second terms. See if it knows what I mean by that. Yes, actually, that is yeah, add less than add, please. Not add less than. That's almost right. Okay. Good. That is what I want. So I split it up into the first inequality, which is strict. Okay. So there, I think G conquer will work. Hopefully. All right. And the second one, which is non-strict, I think also G conquer will also work here. All right. So I have that. There's some ring manipulation. Okay, and then somehow this is getting bounded by epsilon over 2. Yeah, yeah, because see what he's trying to do here. Epsilon. Got this, which is almost half of epsilon. It's almost half epsilon, and then it's and then this weird. This product is actually not super good. Yeah, so it's a low order term. It's got 2 epsilons in it. It should be. I think I'm going to do this a different way, actually. No, actually, no. I could bound this by 1. Then this would be by my epsilon over 2L plus 1. And I could basically sneak it under this term here, I think. Yeah, I would change the parameter choices in the whole proof, but I think first of all, let's just see this work. Okay. Let's see if it can do a complex change like this. All right, so we are changing what our epsilons are. Okay, unfortunately, it did mess up a few things. Let's see. What are you trying to do here? Why do you want 3MG. Well, that's true, but oh, I see. Okay, now I know why they wanted +1 because I'm dividing by 0 now. I'll just undo that. That actually. Okay. Now I understand why they put a +1. Okay, so we're back to here. All right. Round this by 1, then I can put I can absorb this term into this term here. So I think I can just force that. I'm going to replace. Okay, so instead of epsilon over 2m plus 1, we can pick any positive epsilon for our continuity statement. So what we're going to do here. Minimum of this. Yeah, that and 1. There we go. All right, so I'm going to improve the convergence of the minimum. I'm going to improve the convergence of F, I think. What am I doing wrong? Okay. I could also do it for, yeah, okay, I'll ignore that suggestion of GitHub. I just want to get F to converge better. Okay, so now this was, this made this slightly worse because, right, so now fx minus 7 is actually bounded by, not this quantity, but by the min of this quantity in 1. So let's see, let's fix this. Change the, x, so that now fx minus L bounded by the minimum. 2m plus 1 and 1. Now we need two steps here. First, to bound fx minus L, the minimum, and then bound by epsilon over 2 epsilon. So let's see if we can figure out how to do that. I did. Okay, yeah, so first bound by the minimum, and then used a standard lemma that the minimum is bounded by one of the two terms. Okay, so that's good. Okay, the whole reason I did this though is because I get another bound. I want to also say that f of x is bound by L plus 1. Actually, this might work. Okay, yeah. So we right, we split it up. We use the triangle inequality. We bound this, but not by epsilon. We want to bound this by the minimum of epsilon. Yeah. So you don't use commas for. Well, this is a bit messed up. This. Yeah. Let's see. Use actually okay, no, the limit should work. Okay, that is a limit. Okay, so then I want to bound this minimum by 1 actually. You don't have an idea here. I'll just do myself. Okay, so we can cancel off the L's. Wait, we can't because I didn't do it correctly. Right, and I want min less than 1, and that should just be it's should just be min the right. Okay, there we go. Coming. Now, what is it complaining about that? Oh, 1 plus L is not L plus 1. Okay, fine. Okay, that we can fix. Okay, yeah, that works. Okay, hang on, still complaining. Oh, okay. Just because I want this to be, let's put up to that here. Okay. All right. So I got the second bound. So now that should, I can use that here. Oh, wait. Actually, I have to change quite a few things. Okay, well, I should have just do a pen and paper calculation here first. Okay, so maybe I have to change my truth here. I wanted to bound fx by L plus 1 times an epsilon over something plus m times an epsilon over something be less than epsilon. That's what so actually the correct denominator that will make things line up nicely is actually that. Okay, so I'm going to go back and change my proof. Yeah, this is where it would have been better to actually do things by pen and paper first before just doing it cold, but maybe this is also a constructed demonstration. Okay, so I'm just going to change my parameters here. You can see one nice thing about formalizing actually is that the first time you set up a proof, it is tedious. But changing a proof by modifying parameters actually is remarkably straightforward. You just need to find all the red places and and just fix them. And if you did things correctly, nothing really has to change. Yeah. So all right. So GitHub has included in what I'm doing. So it's actually changing things for me. Good. All right. So right. So now I think I can proceed. Yeah. So I want to balance by L plus 1 times epsilon L plus 1 and then m times, yeah, that is actually what I want. Oh, okay, and that actually worked. Okay, I don't really need to change the comments, but oh, I'm suggesting fixes. Let's see. So this is I think I want, let's do this. If I've done this correctly, this should actually just equal epsilon. All right. There's a technical, I'm curious if GitHub Copilot knows this. This step should just exist in denominators. Use them. All right, so it actually got as far as this. This should just be a method library tactic. Let's see. I'm really lucky. Look. That actually could be the right tactic. There's no div cancel. Oh no, that's not quite right. It's a group. I bet what's holding it back is that it doesn't know that L plus M plus 1 is not 0. Let's see if I, yeah, if I make it positive, then this should work actually. Yes, okay. All right, so it got a bit chaotic at the end, but I think I actually did prove this this lemma as well. Yeah, so you can see that past a certain point of complexity, Github Copilot does become a bit unreliable, and so it's better to switch to more human methods of proof at some point. In particular, it would have been more efficient if I had written down with pen and paper a proof of this fact first, and then try to formalize line by line, and maybe get all the epsilons correct first. But you can see that it this Github Copilot tool does get you started. You just have to know when to use it and when not to use it. Okay, so thank you for watching.